Hi, my name is Amy Cabrera. I graduated from UCI with a bachelor's in mathematics and a teaching credential from the CalTeach program. The CalTeach program at UCI is a unique program where students get a bachelor's in science or math and a teaching credential. Today we will be talking about inquiry, a topic that's really important in the CalTeach program, and showing you some of the best practices.
Inquiry-based practices. This picture shows traffic signs used in school crossing in different countries. What do you notice? And what do you wonder? The more we reflect upon these images, the more questions may pop into our minds. For example, you might ask, why is the Chinese sign not red? In the United Kingdom sign, why did they choose a female to accompany the child as opposed to a male? Why are the people in the United Kingdom patiently walking, while in the other signs the people seem to be in a hurry? Why do the Italian and Chinese signs include a briefcase and a lunchbox, while the other signs do not? Why are the people in the United Kingdom walking in the opposite direction from the people in the rest of the signs? If you are the person formulating these questions, you are probably curious to find out the answer. You will feel motivated, you want to investigate, and you will probably remember the answer to these questions for a long time. If someone showed you a narrative describing the various characteristics of the school crossing signs in different countries, how much would you care? How much would you remember of what you read? The same thing happens in mathematics. For example, a traditional lesson on percentages may leave students unmotivated to learn, perhaps even confused. Students won't be interested if we just ask them for numerical answers, and they may not care much about our mathematical explanation. Why should fractions or percentages matter to them? By investigating the questions they created, the students have more power in their learning. This brings us to the topic of inquiry. Which task would you rather as a student? Which one stimulates your curiosity more? Which one makes you think more? And most importantly, from which task will you learn better? Consider instead starting a lesson with this statement: no questions, no explanations. Just show your students the claim and give them the opportunity to ponder and make the problem their own. Let them wonder. They could ask themselves whether the statement is true and immediately compute an example in their head or on their notebook to check if it works. They may want to know whether this is a coincidence or if it works for other numbers. Does it work for all numbers? By investigating the questions they created, the students have more power in their learning. In this example, they are able to explore the definition of percentage, they will do some computation, explore and discover interesting properties in a way they made their own. They will be more engaged with the material and they will learn it at a deeper level. So let's go back to what is inquiry-based teaching. Inquiry-based teaching is based on the constructivist learning theory that states, knowledge is not passively received, but actively built up by the cognizing subject, and learners construct their own meaning and understanding based on their experiences. Why is it important? First, it promotes deeper learning. When teaching with inquiry, we focus on the process used to arrive at the answer, rather than the answer itself. It is through the process of figuring out the answer that the student constructs meaning for him or herself, and concepts are internalized. It supports females and minorities. Students come to the classroom with a variety of mathematical experiences. When teaching with inquiry, we allow the student to draw from and build upon these experiences. Teaching with inquiry allows to engage even the most math-intimidated students because it starts from what Dan Meyer calls the level playing field of intuition. We are training students to become patient problem solvers and be inquisitive. Showing students that there are multiple ways to solve problems and encouraging creativity will foster persistence and love for learning. Finally, students are actively engaged in the learning process, and they are encouraged to communicate and explain their ideas. Inquiry and equity are inseparable aspects in the instruction of mathematics. In particular, children from marginalized groups have experienced limited access to high-quality mathematics instruction. History shows that school mathematics has evolved in ways that have systematically excluded children of color from access to content. Children have also experienced racial stereotyping. Empowering students to pose their own questions and investigate them is a way of honoring students' own identities in the mathematics classroom. So, what is the role of inquiry in mathematics? Mathematics is a creative activity, and asking mathematical questions is an important part of doing math. Unfortunately, there are common misperceptions about the use of inquiry in math. For example, some think of math as a static body of knowledge that gets delivered to students. This view of math limits the potential for student engagement. Students mostly answer questions posed by their teachers or books. They are given few opportunities to ask their own mathematical questions. Not allowing students to follow their mathematical wonderings shuts down engagement. Math is a creative activity. Asking mathematical questions is an important part of doing mathematics. Mathematics is often created through a process of inductive reasoning. First, in math, we make conjectures by analyzing the structure of a few sample cases, and then we prove that conjecture through careful deductive reasoning. Teaching mathematics with inquiry means to create opportunities for students to explore and investigate their own mathematical questions. It includes less focus on passing factual knowledge to students, more focus on independent problem solving. Less focus on merely computing and manipulating formulas, more focus on understanding. Less focus on isolated problems, more focus on problems within a context. Not only focus on acquiring particular math skills and results, but also focus on the necessary learning processes and strategies. There are two types of inquiry: teacher-guided inquiry and student-guided inquiry. Inquiry-based instruction often combines the two. In teacher-guided inquiry, instead of simply presenting facts, the teacher poses questions, problems, and scenarios to help students learn through individual thought and investigation. Though inquiry is present, the teacher orchestrates and guides the discussion, probing questions to move student thinking along a predefined solution path. In student-guided inquiry, the teacher lets students ask their own questions, essentially providing their own inquiry. The teacher encourages students to draw on their own intuition to understand the problem and pursue their own ideas to solve it. Sometimes, this results in students creating original solutions to the problem. Other times, it ends in contradicting results that make students become aware of their own mistakes. Both outcomes are valuable. The teacher provides scaffolding when students are stuck, but this is done by suggesting tools and strategies rather than by asking questions aimed at directing the students toward a specific solution. But what does it take to promote inquiry? In order to allow students to participate in inquiry, you must create an environment where students feel secure in sharing their thoughts and asking for help when needed. To create such a non-judgmental environment, you must instill a culture of sharing and respect in your group, where students feel comfortable engaging with their teacher and peers. Caring relationships are key, especially when working with students from disadvantaged backgrounds. Mentor preparation is also essential when teaching by inquiry, especially if you're using student-guided inquiry. As a mentor, you want to feel competent and confident to answer all the questions from your students, and possibly anticipate the different solution methods they will explore. Central to this practice is listening to and making sense of students' ideas and using that information as the foundation to help students move their thinking forward. How do we do this? First, be prepared. Think about what you want your students to know or do beforehand. Have guiding questions. Ask them, what happens if? What do we mean by? How do you know? Listen with purpose. Look for evidence of students' thinking. Make sense of it, and build on this to help them move forward. Written evidence of a student's thinking can be through their drawings, symbolic notations, etc. Inform students that there are multiple ways to solve a problem. There is not just one way. Finally, model how students can develop their own questions and use their curiosity to their advantage. How do we play the role of a teacher or a mentor in the inquiry process? Well, we want to play the role of an experienced co-researcher rather than someone with all the answers. Don't give too many hints. Give encouragement for good thinking, not just for right answers. Treat right answers as discussion topics until the class agrees on them. As soon as you acknowledge a right answer, you often shut off thinking about the problem, even if students don't understand the answer. The goal for students is to experience mathematics as a process of finding and connecting ideas. Let students know that the thinking and problem-solving skills that they develop can serve them in all aspects of their lives. All right, so this is the activity portion of this video. This activity is called the Square Dance, and it's adapted from a problem from the Julia Robinson Math Festival. Let's start off with the rules. So our first rule is that we have 16 dancers. We've got 16 of these people, and we're going to number them 1 through 16. So each gets assigned their own number. Okay, and now we want them to find partners for this square dance. But because it's a square dance, of course, we're going to ask them to find partners where the numbers add up to a perfect square. So I'm going to say partners must sum up to a perfect square. Let's illustrate this a little bit. So say for example, I'm square dancer, that's me, and my number is number 1. Now I could partner with square dancer number 3, and let's see why. So if my number is number 1, and I want to figure out the sum with my partner, let's add it up. And we get 4. And we can rewrite this as 2 to the power of 2, which is our perfect square. Fantastic. Okay, so now our goal is for everyone to find a partner. But let's ask ourselves a couple questions. We gotta know, does this even work? Is this possible? And then if it is there more than one way? Is this a unique problem? Sweet. All right, now that we have the rules and the question all laid out, let's talk about how we can use inquiry to help guide a group of students through this activity. So I'm going to give you actually a minute to pause this video and come up with questions on your own. And then when you're ready, you can play the video again and we'll go through the questions that we've developed for the types of inquiry that we can apply. So I'll give you a second. Okay, welcome back. So in our video, we discussed how there are two types of inquiry: teacher-led inquiry and student-led inquiry. So I'm going to be going over both of them and how we can apply it to this problem. So remember that teacher-led inquiry, we have a bunch of questions prepared, and they help us get students to a goal that we have established. So if our goal is to answer this question, I want to be able to help the students narrow their focus to how we can get to a final solution. So, for example, like a first question I could ask is, what is a perfect square? It's general and it's good for students so that they can go back and really analyze what the problem is asking. This question is good not only for all students, all general students, but it helps students who are English learners go back and ask themselves what the problem is about. All right. This is also a really good question because it narrows their focus to the set of perfect squares. Building off of this question, we can ask them, now, what's the smallest perfect square that we can make? And this is a good question because we're going to make this big group of things that we want to create perfect squares into something a lot smaller. We're breaking down the problem. So what's the smallest perfect square? So we're putting kind of a little bit of a bookend on this. And to complete the other end, we'll ask, what's the largest perfect square? So what we're really doing is funneling their focus. All right. Okay. So after this, they should have a bunch of different squares that they can make. And now we kind of want to ask, what are the possible pairs that can make the perfect squares? So earlier, we discussed how me as partner 1 can partner with partner 3 to make the perfect square 4. That's what I mean by pairs. So partner 1 and 3. All right. And these are possible questions that you can use for teacher-led inquiry. Okay, let's attack student-led inquiry now. The difference between teacher-led and student-led inquiry usually is kind of an emotional investment. So instead of going straight off the bat to what is the largest perfect square, we can ask them, do you like dancing? And the reason why this is a good question, even though it might not be focused on the problem, is it's a chance to connect with the students. Because you're asking them something more personal, they'll open up to you. If you share something about yourself, if they feel connected with you, they're more likely to take risks as they solve the problem. All right. So now let's get some more clarity on the problem and ask them, what is the problem asking? And this is important because instead of going with what is a perfect square right off the bat, with the fact in mind that we want them to understand the problem, we get their own understanding of the problem first. And this is super powerful because it gives them a lot of ownership inside of the problem. This is your chance to listen carefully, and look for evidence of understanding, not for anything to correct. No matter what they answer, don't disagree or agree with them yet. Ask for everyone's opinion. Okay. So now that everyone knows what they want to do in this problem, we're going to look for the matches. So if you feel like the kids have not made sense of the problem yet, you can try to scaffold more, make things more explicit, but you do not need to provide answers or explanations yet. We can keep building on this emotional investment that we've created. So, for example, we can ask them about their experience with problems like this. Ask about their experience. For example, have you ever been to a school dance in which the teacher picked your dance partner? Or maybe told you that you had to dance with a person that satisfied some kind of condition? Was there ever a time in which a teacher told you that you had to sit on the bus with a particular person? What we're doing here is we're making the problem more culturally relevant to them. And it's important for you to wait to see if they share something. If not, you can share one of your stories with them, and that vulnerability, you opening up to them, that's something that'll definitely help you move forward. Just a little note, when explaining the problem, the students might restate the rule as given. They might just go back to the way that we wrote out the problem and restate it. You want to make sure that they understand everything. So for example, we can finally go back to this question we have here in teacher-led inquiry. What is a perfect square? And again, asking this question allows students to focus on the main goal of the problem and narrow their focus to the set of perfect squares. And maybe at this point you can ask them to make a list of perfect squares. This is relevant to the problem, and remind them that it might be useful later. So, what are some perfect squares you can think of? And then you can have them write this down on the whiteboard. So a student might say, "1, 4, 9, 25, 36, 49, and we'll go back to this later, just in case we need it. All right. At this point, we're safe to assume that they've made sense of the problem. So I would suggest we give each group of 2 to 3 students 16 Post-its. So this will be really neat. If you give all of them a number to actually model this problem in real life, and give them time to explore and play around with the numbers, they can find the answer. Okay. So that's our activity and how you can use inquiry in this problem.